Alright, welcome to Chapter 14, Section 3, Using Heat. And let's get right to the key ideas here. What happens to heat energy when it's transferred? What do heat engines do? And let's move past the bell ringer. So, what happens to heat energy when it is transferred? The first law of thermodynamics states that the total energy used in any process is conserved, whether that energy is transferred as a result of work, heat, or both. Second law of thermodynamics states that the energy transferred as heat always moves from an object at a higher temperature to an object at a lower temperature. So work can increase average kinetic energy. So mechanical processes which involve energy, or which energy is transferred by work. That's what mechanical processes are. The disorder of a system tends to increase over time. In any given system left to itself, the entropy of that system will tend to increase, which is basically a disorder of the system, where it basically loses heat. And entropy is just a measure of the randomness or disorder of a system. Usable energy decreases in all energy transfers. So if energy increases, less energy is in usable form. It gets released. You can't use it. So conduction and radiation may cause energy to be transferred to the surroundings. So what do heat engines do? In a heat engine, potential chemical energy and internal kinetic energy are converted to mechanical energy by the process of combustion. So a heat engine is a machine that transforms heat into mechanical energy or work. Internal combustion engines and external combustion engines are the two main type of heat engines. Internal combustion engines burn fuel inside the engine. An automobile engine is a four-stroke engine because four strokes take place for each cycle of the piston. That's between the spark. It goes four strokes to the next spark. Four strokes are the intake, compression, power. That's where the spark plug sparks and ignites the gas. It powers the cylinder down, and then you have the exhaust cycle. Internal combustion engines always generate heat. That's why you have to have a cooling system on those. Friction and other forces cause much of the energy to be lost to the atmosphere as heat. And as you know, when you've driven a car for a long time, you can touch the hood and it's hot, or that engine's hot, and it gives all that heat off to the surroundings. As that heat goes away, energy is lost. Automobile engines use carburetor or fuel injectors. Carburetor is basically a part of the engine in which liquid gasoline becomes vaporized. Gasoline only burns when it's vaporized. Some engines have fuel injectors instead of carburetor that aerosolized the gas, or vaporize it basically. So internal combustion engine here. Here's a depiction of the four strokes on an internal combustion engine. As the piston goes down, as it's rotating, the piston is going down. It's pulling in gas, vapor, and air mixture into the cylinder. As it rotates, it goes back up, both valves close, and it compresses that air-gas mixture here when it gets to the top, and then the spark plug fires, and that release of chemical energy is a power stroke. It pushes that piston back down, which is now turning the crankshaft, and then as it rotates back up, the exhaust valve opens and it pushes all the exhaust